So to summarize the two cases that we took before, if the magnet is moving up, in this case with this north pole up and the south pole at the bottom, the magnet's moving upwards, we ask the question, what's happening to the magnitude of the magnetic flux? In this case, it's getting bigger. So the thing was, the induced magnetic field wants to be in a direction to prevent the magnetic flux from getting bigger. So how would you prevent the magnetic flux from getting bigger? You make a magnetic field opposite the original one. Then you ask the question, what's the direction of the current that will make that magnetic field? So if you put a current in this direction, it'll make that induced magnetic field. If you move the magnet away from the ring, then the magnetic flux magnitude is getting smaller. So the induced magnetic field wants to be in a direction to prevent the magnetic flux from getting smaller. It always wants to prevent it from doing what it's doing. If it's getting bigger, it wants to prevent it from getting bigger. If it's getting smaller, it wants to prevent it from getting smaller. So it's in the same, so the induced magnetic field will be in the same direction as the original one. And then you can ask the question, what's the direction of the current that will produce this induced magnetic field, which is this direction? What about this case? Can you figure out what direction the induced current would be in this case? Here I flipped the magnet. You have the south here and the north here. About this case, this case, this case. Try and do those on your own.